guess I'll turn myself on. Is that a little easier to hear me back there now? Can you hear me coming out of the monitors? Okay. Is that a little better now? All right. Well, go ahead and get started then. My name is Ken Moore. I'm an employee of IX Systems, and I work in one of the core developers for the TrueOS project. I am also the man behind the curtain, so to speak, of the Lumina desktop. It was my baby. I did it in the evenings. I started working on it during the day at work hours at IX Systems because I said, hey, this is cool. We're going to need this for TrueOS eventually, so I got to work on it all the time once I proved that, hey, this is actually something that's going to turn out really cool. So yes, you can blame me for everything associated with this. Let me just make sure that it's already there. Didn't it? Okay. So there's just a few key questions that I want to talk about. It's probably things that you may have come to mind when you were using a desktop, may not have, but these are kind of the underlying things that go into how a desktop works. And we're going to try and address these and just formalize them and say, okay, what is this? So first off, what is a desktop? It seems like everybody I talk to at these conferences has a different definition of what a desktop is. So let's just set the groundwork. We'll try and define what a desktop is to start with. All right, and then we'll go into, all right, how is a desktop assembled? And then how does that transition for all the various desktops that you know and love from Linux? How does a desktop integrate with the operating system? That's also one of the big key features is, okay, that affects portability, that affects all the other stuff, or what can it do? And then how is Lumina 2 any different? So Lumina 1 is out and available right now. We're on version 1.3.3, which is the development version. The latest release version, the public version for all the operating systems, is 1.3.0. The extra dot is what I use for development changes as I'm working on stuff. It's like, oh, this is a significant change. Let's just bump the development tag. That way we can keep track of what version people are on. So let's go through what a desktop is. Here is what you see are like the three common answers that I get to the question, what is a desktop? First, people say, well, it's everything. It's a complete graphical system with a collection of various utilities for common tasks. For example, they point to KDE or GNOME or sometimes even XFCE. You install that desktop, you've got everything. You don't need to install anything else. You've got an Office suite, you've got an email client, you've got a web browser, you've got text editors and multimedia or applications, the whole kit and caboodle. It comes with everything. That's a desktop. And then you have people that say, no, not all of that is the desktop. The desktop is only the interface. It's only what in KDE land they now call Plasma. That's the desktop, not the applications, just the workspace itself. So that's what gives you the application shortcuts. It manages the windows. And that would be something like KDE's Plasma or Lumina 1 and 2, or just, for those of you that are do-it-yourselfers, take something like OpenBox or i3WM or something and then add a dock to it with some other application. So something like CairoDock or, mix it with something else or i3Dock so that you build your own. And a lot of people would say that's the desktop. But then you have people that are even more minimalist and say, no, you only need window management. That's the only thing you need to define a desktop. And so somebody like that would say, oh, just running Fluxbox is a desktop. Just running OpenBox or just running i3WM, that's a desktop. So you have a large range of things that are considered to be included in the desktop depending on who you actually talk to. So I would propose this for the definition of what a desktop is, because I think it really cuts to the meat of the issue. A desktop is a graphical interface to an operating system which supports industry standards for application interactions and controls. There are a whole host of free standards. The Free Desktop Group publish what are often referred to as the XDG standards. So that things like star.desktop files, that's a very specific standardized format. It's a text format, but it's a file that tells you, oh, this is how to launch an application. This is what icon it uses. This is the tooltip and extra information. It gives you standards for all of that information. So where this ends up breaking down is I have some examples here of a couple of the other standards bodies. For window management itself, you have the ICCC-M and Extended Window Manager hints. I can't remember what the ICCCM expansion is. It's just an algorithm, it's just a collection of letters to me, but yeah, that's one of the older standards, and then the EWMH is the newer standards. The XDG desktop menu and entry specs, that's some of the newer specs by the free desktop group, specifically involving .desktop files and things. There's a whole set of other specs from the free desktop group as well, specifically regarding things like theming, cursor themes, icons, color schemes, all sorts of things like that. That starts getting a little bit debatable as to whether or not they're official specs or just guidelines. I mean, even in the free desktop group, they'll say that. So you start running into a little bit there, but with this definition, what you see is you start seeing the breakdown of all stuff. You would say that, okay, KDE is a desktop then, GNOME is a desktop, that's kind of what you expect. They build themselves as desktop environments. But then something like LXQT, LXDE, yeah, those would still be desktops too, even if they don't give you their own self-built web browser, or they don't give you their own self-built, whatever application, because that's not technically part of the desktop. By the same token, a lot of the window managers would not fall under this definition, something like OpenBox, for instance, because it's just providing the basic canvas. It doesn't necessarily do all the standards compliance. So it starts to provide that little bit of distinction there. It's like, okay, what can it do? Does it adhere to common standards, or is it just doing the bare minimum to put visuals on the screen? So I like to use this for the definition of a desktop, and this is kind of what I'm going to go into. So when I say desktop later on in the talk, this is kind of what I'm referring to. Okay? So let's go into how a desktop is assembled. You've probably seen bits and pieces of this, especially if you run Top or if you run a bunch of other profiling systems on your desktop systems. You'll see something like this. So I've kind of categorized them as they were added to what's called the desktop environment over time. Originally, when they first started with what I would call desktops, originally you just had X11, and it was designed to start X to run one application, and that was it. So that's pretty much all you had. And then they're like, oh, well, we want to run more than one application now. So now we need to run X to start something else called a window manager to let you run multiple applications in Windows. And then it's like, okay, well, now if you've got that, now you have to worry about the wallpapers or icons underneath the windows, and you can see how the desktop started getting assembled and built up over time from there. So they added wallpapers, they added reserved screen areas called panels, or sometimes they call them toolbars, or there's different terminology for this. And then they said, oh, well, now we got to start worrying about what if you want to lock your session? What if you want to do screensavers for some of those old monitors? They had to add those as extra components. Clipboard, global clipboards, global keychains for things like SSH keys and stuff like that. Later on, it's like, okay, now we need a formalized application launcher system. Because it's getting so big, we now need a formalized way of launching applications so that everything gets launched the same way instead of expecting everyone to do it from the command line manually. And then, oh, well, it's gotten so big, now we need a session manager. Now we need to write a utility to manage all the other utilities that we wrote for the session. And then you can see that they started adding all sorts of other stuff. So now it's pretty much common practice that a desktop also includes a file manager. If you look at most of the common file managers out there right now, almost all of them are associated with desktop projects. You still find a few on the side that aren't associated with any desktop, but they're getting rarer and rarer. Service manager, device manager, network manager, file sharing manager. You start seeing that, especially when it comes to the built-in file managers like Ocular and stuff. It's like, oh, that manages your file sharing now. That manages the connections to Samba or NFS or whatever. And even package manager, you're starting to see some rumbles of that now with the desktops getting involved in how to install packages and how to actually deal with what applications are installed on the system. So you can kind of see there's this trend of how the desktop has kind of been built up over time and how more and more and more stuff keeps getting glued onto it. If you start trying to categorize this, you start to see a little bit of a trend. Initially, it's focused just on the graphical session. You see, okay, I'm just dealing with the windows, I'm just dealing with the wallpaper, I'm just dealing with, the screen itself. After that, they started dealing with, oh, wait a minute, now we're writing things that you might not see. They're running, but they're designed for applications to hook into. So the global clipboard, the keychain manager, now the applications don't need to do those themselves. Now they're hooking into something that's already running on the system, which is provided by the desktop. Same with the session manager and things like that. Those are ways of managing all these applications. They started adding stuff for the applications. And then this last phase, you can see they're really starting to go gangbuster on trying to do things for the operating system. So now you use the desktop to control the operating system and tell the OS what to do. So now it's like, oh, now we're starting all these services. You go through us to kill services. You go through and do this. You can obviously do it from the command line, but you're starting to see a lot of creep from the desktop itself as to, no, we're starting to manage some of this. So you can start to see these trends. The immediate question that comes to mind then, especially with this last phase, all right, this is just a desktop we're talking about. Where is the operating system? Where does the desktop end and the operating system begin? There's starting to be a lot of bleed over, a lot of common areas that both of them are fighting for control over. So this leads directly into the next question. And by the way, let me just tell you right here, if you have questions on any of these slides, please raise your hand. I love stopping and talking about this. So we'll go on. And if nobody has any questions about that. No. Okay. All right, so let's lead into the next question. So how does the desktop integrate with the operating system? Where do you start to see those boundaries and those borders? So if you look at the traditional operating system, this tends to be your command line only, your server-based operating system. The operating system provides a system console, a terminal, usually. It tends to be keyboard only, but the operating system manages what users and groups are available, how you actually log in to the system. It manages networking devices and how that's actually done and packets are sent. It manages services, because services tend to be non-graphical. So the operating system itself is usually responsible for anything non-graphical, and it has its own service manager. It could be OpenRC, it could be now systemd, it could be all sorts of stuff for that. The file system itself, the desktop again, generally stays to the graphical side of things. So the operating system is what manages the file system. The operating system is what sets, what thing do you need here? Same with your shells, because that's your command line interface. Your command line representation of the operating system tends to be your shells or your terminal. Similarly, the hardware drivers, and they provide some standard libraries, usually C libraries. If you go to some of the other operating systems like Windows, you'll see they provide standard libraries, but they might not be C, they might be like C# or something in that case for Windows. And with Apple, they have their special, I can't remember, is it Objective-C libraries? So that's kind of been the realm of the operating system. Everything that's basically non-visual, that you can run directly without any X involved, without any graphics drivers, without even a graphics card installed, pretty much anything there, that usually falls under the realm of the operating system. The desktop provides the quote-unquote graphical console. It's kind of like how the terminal is the text representation of the operating system. The desktop is the graphical representation of the operating system. So the keyboard is optional. It tends to be more flexible with regards to inputs for users. So you can use a mouse, you can use touchpads, you can use keyboards, you can use whatever you want. There's all sorts of devices that you can use. Most of those all fall under the realm of the desktop because they allow for a larger variety of input from the user. It still tends to be multiple user as well. It's like, okay, you could have multiple sessions at the same time, but then they ask the operating system, hey, can this user log in? Multiple applications. It's designed to run multiple things and show all of them at the same time, whereas a standard console is designed to show one thing at a time, unless you run it through some other application like Screen that lets you run multiple things concurrently, and then you can switch around back and forth between them. And then they also provide standard libraries and stuff, either the X11 or the Wayland libraries. They also tend to be C libraries. So there is a lot of analogies between the non-desktop, the operating system, and the desktop system. They do a lot of the same things, but they're designed and focused on different ways, so they have just different ways of approaching the same problem. So let's keep going at this. How does it tie into the operating system? If you, again, looking at the trend, you're starting to see a lot more OS intrusion by the desktops. File system interference. How many of you run GNOME? How many of you realize you're running your own virtual file system just for GNOME? Called GVFS. All right? So basically, the desktop doesn't talk to the native file system. It doesn't talk to the operating system file system. It talks to GVFS. and GVSS is its own layer. So now you have to go through at least 2 transitions just to get to the file system. You have to go from the desktop to GVFS, GVFS to bounce around in there, and then to bounce out to the file system, and then back. That adds a lot of time delay, adds a lot of interference between actually doing stuff with the operating system directly. iNotify is another one where it tries to, again, provide a shim layer to try and get file system events and notifications and stuff. iNote events. Yes?
Where does iNotify come from?
I'm not sure exactly. It comes from the Linux community. I can't remember exactly which project started putting that. I know that's one of the pieces of GVFS, so it might come from the GNOME project. But it could be something else. They're like, ooh, we like that, and we'll just use it.
I remember using it when I had Ubuntu, but I don't remember using it since I switched away from running GNOME.
Yeah. So it might be something from here. I don't know where it comes from, but it's just another example of something that interferes with the workings of the file system from the operating system itself. What about bypassing user restrictions? You've used PolicyKit, dbus and stuff. Are you aware that a lot of that is specifically designed to bypass user restrictions as set by the operating system? So dbus in particular, you start a root dbus session, and then you can talk to the root session to tell it to do things, even from your user, even if your user doesn't have permission to actually change to root or do anything like that. So it's a way of getting around the system-provided permission settings. What about removable device management, bypassing that? How many of you use HAL-D? Or an auto mount system, or an auto run system? Sorry, my slides are getting cut off just a little bit on the side there. But it's like, okay, when you plug in a removable device on GNOME or whatever, what does it do? It automatically mounts it on the file system. So it's basically exerting control over that device instead of letting the operating system do its thing with it. It says, no, I want you to do this, I want you to do it this way, and is that really the way it should work? Shared network protocols. I mentioned this with file managers. If you want to browse a shared network in KDE or Plasma, you use the Ocular File Manager. The file manager is what sets up the Samba connection, is what sets up the NFS connection. And it's going through the file manager to actually talk to the shared network. It's not going through the operating system. Is that really the right way to do it, or does that fall under the realm of something the operating system should be controlling? Hardware management. What about things like UPower? It tries to provide its own power control mechanisms for the operating system instead of just using whatever the operating system already has. And I think basically when you look at all this stuff and what you see is going on in the desktops, it immediately begs the question and makes you realize that what's going on is that the desktops are trying to enforce standardized operating system interactions. All the desktops want the same things from the operating systems, but they're all doing it in different ways. So essentially, what they need, they just need an operating system API. There needs to be a standardized API for operating systems and desktops to communicate with each other. Right now, it's kind of been hit or miss. Everybody's like, oh, I'll just use this utility for that, or that utility. But that'll be different for some Linux distro as opposed to FreeBSD or OpenBSD. We have different utilities for things, but oh, that desktop doesn't use that. It says, I only want that one utility, which doesn't work on other operating systems. So let's go into the same questions, but let's go through it a little bit more about how Lumina is different. Yes?
You mentioned Ocular file system, or Ocular...
How it does the file sharing protocols and hooks into that.
I'm only familiar with Ocular being a PDF reader.
What was that?
I'm only familiar with Ocular being a PDF reader.
Dolphin. Thank you. Yes, not Ocular. You're right. Ocular is the PDF viewer. Dolphin is the file manager. Sorry. Yeah, Dolphin and Nautilus for GNOME. Actually, they may have changed that, didn't they?
There'd be GNOME files, I think. And then
yeah, I think they changed that. It's no longer Nautilus. It's something else for GNOME now. But anyway, yeah, sorry. Thank you for correcting me. Yes, Ocular is the PDF viewer, not the file manager. All right, so how is Lumina different? So let's go into the question, okay, what is the desktop? So what you see for most of the common open source desktops, they're all developed on Linux, and you see mainly they come under these couple groups. KDE/Plasma, GNOME, and other derivatives. They all tend to take the all-in-one approach. There's lots of dependencies. When you install KDE, for instance, how many different packages do you have to install? How many different utilities does that install with it? So those take definitely the all-in-one approach, where it's like you install us, we take over your system, you don't need anything else. All you need is us. All right? You could install other applications, but you don't need to. That's their methodology. They assume that, oh, okay, that from a developer perspective, from a desktop developer perspective in the first place, that actually makes a whole lot of sense. You want something like that when you're working like on a small appliance, something that the user doesn't have direct control over. They can't go and install other stuff. You want to make sure that there's one thing that you install as a distributor, and then that's it. You don't have to worry about anything else. You don't have to worry about the user customizing it. So that makes more sense from an appliance standpoint, not so much for like a global universal desktop standpoint. XFCE, LXQT, and Lumina 1 fall under more of this other category. It's a little bit more modular. It's independent from the applications, that we try to separate the desktop from the applications that you're running. It's primarily just the interface, so it would be corresponding again to Plasma. But it usually still requires several runtime processes. So when you say start the desktop, it doesn't just run one thing, it runs a few things. It starts up the window manager, it starts up the session manager, it starts up the desktop, the key manager. It starts up, all those various utilities that we talked about earlier. So you still have some of that there. Where Lumina 2 is different, Lumina 2 is still in development right now. It's the next major iteration of Lumina, and we're proceeding very, very quickly on this. It also follows the interface-only approach. But there are a couple things here. It does not require any operating system services. And this becomes really important when you start looking at actually your startup times and your boot up times, especially on any of the BSDs or whatever. How many system services do you have to start before the desktop itself can start? Do you have to start up something like HAL-D? Do you have to start up dbus? Do you have to start up console kit or systemd, whatever. Systemd's absorb a lot of that, but you see where I'm going. What else needs to be there before it can run? With Lumina, nothing. Lumina 2, it's a single binary that you can just run directly. I mentioned the single binary next slide. Anyway, it only requires a couple libraries. It requires the Qt5 libraries only, and a couple X11 libraries at the moment. We do have plans to move to Wayland eventually, and we've already compartmentalized our code so that all the X11 code is in one or two very distinct spots. All we have to do is redo that without touching anything else to switch to Wayland. And it's completely independent from the applications. So it is completely separate. None of the applications, it doesn't install libraries. The applications look to and expect to be there to run. So like the KDE applications expect KDE libraries to be there. You don't get any of that with Lumina. Lumina is a standalone thing that's just the interface. You don't have applications written for it so much. They don't require that it be running. Sorry, just a second. So basically, it kind of breaks down like this. What is a simple task, when you start opening it up, actually ends up being just a little bit more complicated. You have a number of moving pieces in there. And this is much more so with Lumina 2 because we're simplifying it for the end user. You're seeing one thing, one process, one binary, but we still have to have all those compatibilities. We still have to have all that stuff underneath. So it ends up there's a lot of workings underneath the hood. So this leads into how it's assembled. With other desktops, they just glue on other binaries and processes. Oh, somebody wrote this utility I really like. I'm going to require that for the desktop, and maybe I'll automatically start it and stuff. That's how a lot of it happens. They generally use dbus as their inter-process communication glue. So when you start the desktop, it sends out a billion dbus calls saying, hey, start this, start that, start this, start that, start that. Oh, is this running yet? No, okay, wait, keep asking it again if it's running yet. Things like that to try and get the timing events so they don't run into race conditions and stuff. It's very, very hideous if you try to map it out. I did that once and I looked at the screen, it's like, there's no way I can show this. It's too hideous. All right. Similarly, they're moving toward the concept of more apps as services. So wait a minute, your application is running even if you can't see it. There's no way for the user to know it's running, but it's still running. That eats up a lot of CPU, that eats up a lot of memory, even if the user can't see it and can't stop it because they just don't know it's running in the first place. You see that especially in a lot of phones and stuff, like the iPhones and the Androids and stuff. How do you kill an application? You close it. Oh, wait a minute, that didn't actually kill the application. It's still running, you just don't see the window anymore. It's that kind of thing, but the Linux desktops are even more moving towards that mentality. They also tend to have a highly fragmented core. They install a bunch of libraries, they install a bunch of binaries and utilities, and they kind of expect that all of them be running in some magic sequence so that things start up properly. With Lumina 2, as I mentioned just a minute ago, it's a single binary. It does not install any libraries of its own. It is literally a single binary. It is a single process. Highly multi-threaded, highly fragmented on the inside, but you get all those speed boosts by things talking directly to each other within the same process without having to dial out through all these external frameworks. This gives you a much, much faster response time and a much, much better performance. We also have been going towards a formalized JSON API for applications or users via scripts or things like that to talk to the desktop, to ask the desktop to do things. So you basically run the Lumina desktop command and say, Lumina desktop, and then here's a block of JSON to say do this or whatever, and then the desktop will do it or not, depending on the situation of the desktop right now. For instance, if the screen is locked, you don't want to have somebody scripting, hey, I want you to launch this application and do this and do that. You don't want to do that when the screen's locked. All right, they shouldn't actually be doing anything like that. Similarly, we have what's called transient applications. That's, I would say, the older style of applications. When you see it, it's running. If you don't see it on the screen and you don't see it in the task manager, it's not running. We've actually stopped it. All right, we take more of that approach to applications. Similarly, we have a unified core, and it's independent from all those extra applications. You can install GNOME applications. You can install KDE applications. Lumina doesn't care what the applications are. You can install anything or everything that you want, and they'll run just fine. Because all it's doing is the standardization for the desktop and the interface itself, and it'll interface with whatever it needs to, following the standards. So basically, it kind of comes down to this picture. This is a good just visual summary of this. The common Linux desktops are kind of like this. There's a billion buttons. Each one of them does something different. Trying to find the right button to push to do the right thing gets to be a nightmare, especially when you start looking at non-Linux operating systems that use different utilities in the back end. All of a sudden, everything changes again. Whereas Lumina 2 is trying to be more the simple approach. We have unified methods, we have standardized interactions, and then we have good highly documented like API calls and stuff like that, so for any standards that we need to create ourselves outside from the universally accepted standards. So simple is very, very nice, but it's also a lot harder to do. Just because there's so much more involved behind the scenes that the users don't actually see. So what about the operating system interactions? Before I go into this, let me ask, is there any questions on that first? No. Are you following? Am I losing any of you? I mean, as the developer, I can dig deep, so I'm trying to just keep it simple up here. All right. So let's go into the operating system interactions. Most of the other desktops are Linux-centric, and what I mean by that is they're developed on Linux, they're distributed for Linux. The dependencies that they require for the desktops tend to be for Linux. This really becomes apparent when you try to port some of these other desktops like KDE or GNOME or XFCE to one of the BSD operating systems. Because Linux is a kernel, and the desktop in many ways has evolved to fill the gap in there of adding to the kernel the stuff that's necessary and providing the standardization of the Linux desktop. Okay? With the BSDs, you have a complete operating system already, and none of that operating system is a part of these desktops. So you run into a conflict between the Linux desktops trying to install and use applications for operating system functionality that conflict with current operating system functionality. So that's the first thing that you see with just the way the desktops are designed there. They often attempt to control the operating system capabilities. Again, by becoming part of the operating system, they're exerting dominance over what the operating system can and can't do. The desktop basically says, I'm the dominant one, you need to go through me. And it provides a multitude of utilities for other operating system tasks. Lumina 2 is OS agnostic. Again, by just being an interface. It's not trying to exert dominance. We actually say the OS is dominant for Lumina. Instead of trying to say, hey OS, they plugged in a device, I see they plugged in a device, I need you to do this to mount it or make it available and open something. Lumina doesn't do that. Instead, Lumina just says and has standardized interactions that says, oh, the operating system just registered a file saying a device is now available and I can do X, Y, Z with it. So Lumina just makes that available to the user, and the user can decide whether they want to mount it, whether they want to actually open it, or do anything with it. It's a very different mentality. It's a much more of a passive desktop mentality. It's letting the operating system do its stuff and then just listening for the standard events and standard messages from the operating system and then presenting those as choices to the user. It doesn't make assumptions about what the user expects to do with the desktop or expects to do with the device. Because for instance, an optical device, let's say a DVD or a Blu-ray, if your file system or your desktop says, oh, they plugged in a device, let's automatically mount it and browse it. With a Blu-ray or a DVD, that means, hey, you're browsing a whole bunch of files on an optical data disk, if you could even mount it properly. Because in order to actually play a DVD or Blu-ray, you can't mount the device. You're supposed to read it raw, as raw bytes from the disk, so that it can be played with the VLC player or things like that. If you actually mount it, you can't access it properly. So again, that just comes into one of the differences. There's a whole lot of variance and differences in how you deal with devices there. So Lumina 2 takes, again, a very, what I would call a little bit more passive of an approach. We treat the operating system as king. We are just an interface for the operating system. We are not trying to control the operating system, if that makes sense. And then, what other utilities do we install for controlling the operating system? Well, none. If you're running Lumina on an operating system, we expect that your operating system already has utilities for controlling itself. Yes?
Does that mean that Lumina 2 would be easily portable to a Linux operating system?
Yes, even more portable than Lumina 1 is, which is already available on Linux operating systems. So yeah, Lumina has already kind of got this, but Lumina 2 is taking it to the next step. Lumina 1 is already highly portable and is ported to all the BSDs, almost all the Linux operating systems as far as I know. We don't do the porting ourselves, but we have a lot of people that work with us to make official packages available in the official repositories. We don't like to say, oh yeah, there's a Lumina package for Debian, you gotta go to this user's repo, he may have signed it, he may not have, you don't quite know what he got, just run a curl command, it's okay, it's all right. No, we don't do anything like that. We try to say, no, it needs to be in an official package in an official repository, so we don't try to provide official packages for stuff that we can't officially test. So it's kind of like this. How many steps do you have to go through to actually ask the operating system to do something? If you want to treat the door like the operating system and say, okay, I want to unhook the chain, how many steps do you have to do? From the Linux desktop perspective, what you often see is that the desktop talks to dbus, which talks to policy kit, console kit, whatever, which then dials out to something like PAM, which then dials out to something else to talk to the OS, and then it has to go back through those same 5 or 6 or 10 steps before you can even get a reply to find out if it's possible. And then you got to do it again, telling it what it can actually do. So it's like this long, complicated back and forth, and it just ends up being like a maze. So it's like it's so much harder than just, talking to the operating system directly and say, oh, the operating system already told me this is the command to do this is the command to do that, and just showing that to the user. So you have one thing you need to do, and that's it. It makes it much simpler, much faster. So, in conclusion, just to kind of summarize this, it's a whole big ball of wax. Again, it's probably stuff a lot of you have seen or maybe even thought about as you were running desktops, especially if you happen to open up the terminal and look at what's going on underneath the hood. But essentially what I think this all boils down to is this. Open source desktops are kind of approaching a crossroads here pretty quickly. Do we follow the example of Windows and try to become a piece of the operating system? All right, because if you look at Windows, you can't really separate the desktop from the operating system. I mean, they're trying to now because they've realized that that doesn't work very well. They're trying to go to things like PowerShell and stuff, and their servers, and try and go more Unix-like in that way, because that methodology doesn't work. But in the Linux desktops, you see them trying to copy Windows more. So it's like you're at a crossroads. Do you want to keep doing that, or do you want to create a more standardized interface, which is more what kind of the universe is going to? Because the interface could be for all sorts of devices. I mean, desktops aren't the thing anymore, right? How many of you use tablets? How many of you use phones? How many of you actually sit at your desktop computer where that is the majority of your time now? I would say that for the bulk of consumers, most people use portable devices now instead of actual desktops. So the desktop paradigm that people like at KDE and GNOME and stuff have been trying to trumpet for a while, they've been building it on this methodology on a particular type of hardware platform, which is slowly going away. It's not going to die out completely because you need systems. You need desktops to get especially a lot of work done at work office spaces and stuff like that. There's a really good use case for it, but it's not as popular anymore because you don't need it for the mass consumer. So if you develop a generic interface, it becomes separate from the type of hardware. It doesn't have to be just for 4K monitors or 1080p monitors and stuff like that. It could be for a little tiny handheld device if the interface is flexible enough. It could be for tablets, it could be for whatever. It's returning it back to the roots of just dealing with the graphical side of things and letting the operating system alone. So with the Lumina project, we're trying to take the other fork, if you will. We're trying to return back to standardization, back to centralized, standardized interactions, and really a much more limited scope for the desktop. We're not trying to do everything. We're not trying to do things, and we don't think the desktop should try to manage the entire system. So that's just the way we're going with Lumina 2. I love this picture. I saw it on somebody else's slide and I had to steal it. But this is probably one of the biggest questions I get when people find out that I was writing a desktop. It's like, why would you bother? There's already so many desktops out there. Why don't you just copy LXQT or do something like that? It's like, no. You have to reinvent the wheel from time to time. The trick is knowing when and how. And that really comes down to the key. Every once in a while you need that little bit of a revolution to reinvent instead of constantly building on the same stale frameworks that don't work anymore. So, and with that, I will go ahead and open the floor for questions. Do any of you have questions? And I believe there's a microphone here. Let me see if this works. So we can ask questions into here just a second. Okay, it does work. So, would you mind handing this around, please, if people have questions? All right, so, any questions? Just for video recording and stuff, we should probably speak into the microphone. Yes, sir.
I've got a couple. Just going through, watching all the slides. First of all, I guess the robustness of the desktop. I don't have a lot of history to prove this, but in my experience, the desktops have been, not as robust as like server level. Sorry. Mm-hmm. Desktops are meant to be rebooted every night, consumer level type of thing. If Xface or GNOME or something starts misbehaving or crashes, the simple solution is reboot the box.
Yeah.
So something like Lumina being a single process, is it something that you could actually drop into a shell or like shell in remotely, kill the process and restart it without having to, that kind of segues into the second question then. From a server perspective, then I'm getting ahead of myself because I don't know if this is even possible, but could we, sort of the way you would X forward a desktop from a remote system, could you kind of put a GUI on top of a server environment remotely, like on a thin client? Say I'm hosting, I got server hardware in a data center somewhere, but locally I have this binary. Could I sort of like pull that information forward to my local, not as it is, but I mean this is like the beginning of something
that exact arrangement, no, but that's actually something we've already done within the TrueOS project. We have a project called TrueOS Pico, where it uses a Raspberry Pi, hence the name Pico, as a remote graphical thin client, where basically you have a desktop server, basically, in the back room. It's not hooked up to any monitors, but then your Pi, connected via network, can find the system and give you graphical prompts to it, kind of like you would get in an SSH session or something, but it's a graphical session instead of a terminal session.
Talking myself out of a job, but putting a GUI on it so the Windows people can manage my Linux boxes when I'm at Linuxfest.
Yes, so the Lumina does make that a lot easier, and we actually have some special stuff in Lumina because we're developing Lumina specifically for the TrueOS project. Even if it's cross-platform, we do have some special glue in there for TrueOS specific projects and things, and that's one of the ones that we have some special things in there for. And it does work very, very well. By the same token, though, you were talking about how desktops are consumer grade. They're designed to be rebooted every night. Lumina's not. Lumina can be run months, uptime of months, all right? And that's actually part of the tests that we do with Lumina. Because with the TrueOS project, we used to actually do that and leave different desktops up for weeks at a time and see what was happening. And we would constantly see with KDE and GNOME that they're either leaking memory or constantly using more memory all the time. And that's why you have to reboot your system all the time to free up all that stale memory and stuff, which they've allocated and not used. So with Lumina, we actually do the same tests, and we make sure that no, it actually does not only free up memory properly, but it returns back down to minimal levels, or even over long periods of time, so that the amount of memory it uses when you first start it up is the exact same as you get 3 months after uptime. So we've gone through and done all those scalability tests, so you don't have to worry about the fragility of the desktop itself. And you can do that with a single binary much, much easier than you can with a whole bunch of binaries all trying to manage memory independently. Yes, sir.
So I run the i3 window manager,
Yes.
and early on I had a lot of trouble getting it to open the right files to the right application, and a lot of this stuff that's codified in the desktop standards.
Yes.
So you end up having to install a bunch of little utilities that you don't know whether they're going to be supported or not. Is it possible to use Lumina as the desktop? Because I refuse to install the GNOME and the GVFS and all of that. Can I install Lumina and use i3 as the window manager?
Yes, officially with Lumina 1, you can do that. We use Fluxbox as the window manager in the back end of Lumina 1, and we require that. But we do have a hook in the configuration option that lets you switch it out with something else like i3. Actually, i3 is one of the most popular options that I've heard from our users.
Awesome.
So, you can do that. You just have to, there's a little warning that, okay, then some of the configuration options and things that Lumina gives you access to, those will no longer work because those expect Fluxbox. So you'll have to configure i3 yourself for that respect. You're kind of on your own with regards to that. But again, if you're already switching to a different window manager, it's kind of understood that you know how to configure it.
i3
So.
you're kind of completely on your own.
All right. I've probably got 1 minute left if I'm supposed to end at 10:45, which I think is the right. So 1 minute left. Any last
When is
questions?
Lumina 2 ready?
When is Lumina 2 ready? Okay. Lumina 2 is in a pre-alpha right now. We have the window manager stuff implemented and functional. We have the screensaver and screen locker systems implemented and functional. We're still finishing up some of the standard support for the window manager side of things. Really, the big thing that we're working on now is we're cleaning up all of the graphics of Lumina itself, because right now we use pure Qt and stuff, but in order to actually do like the window embeds for the window manager and stuff, you really need something better than CPU acceleration. So we're doing a lot of work right now to make sure that we have fully OpenGL and GPU accelerated code for all window graphics and everything for the desktop itself. So that's the next big push, but I'm hoping to have like a beta of Lumina 2 out by the beginning of next year. That's the rough schedule. We'll see how things slip, but that's the time frame at least we're looking at. All right.
At least my
Thanks.
schedule looks like you have till 11.
Well, okay. Well, I will take another couple minutes because I don't see the next presenter in the back anywhere. No? Okay, we'll go ahead and take a couple more minutes. Any other questions? All right, so I have to take a poll now. Now that everybody's here, I have to take a quick poll. How many of you before this talk had even heard about Lumina? About half of you. That's pretty good. I was worried. This is a Linux conference. You see a lot of stuff about Lumina on the BSDs. I don't really see as much on the Linux side, except for our specific people that are making the packages. And we have a lot of people that are very, very happy about it and stuff, but not in the general community. So I'll say thank you very much for coming to my talk about Lumina at a Linux conference.